Number 2 on the 2023 exam, another parametric equation or vector function one. This seems very common on the BC exam, at least in the most recent years. For t is between 0 and pi, a particle is moving along the curve shown so that its position at time t is x of t, y of t, where x of t is not explicitly given and y of t is 2 sine t. It is known that dx dt is e to the cosine t. At time t equals 0, the particle is at position 1, 0. Find the acceleration vector at time t equals 1, show the setup. Part B, for t is between 0 and pi, find the first time t at which the speed of the particle is 1.5. So the workout leads to your answer. Part C, find the slope of the tangent line to the path of the particle at time t equals 1. Find the x-coordinate of the position of the particle when t equals 1. Show the work that leads to your answer. Find the total distance traveled by the particle over the time t is between 0 and pi. Show the step. Okay, so these are, oops, D got totally cut off. My bad. Alright, so these are very standard problems. Okay, and especially if you've been following along in the years, you've been going over each of the problems, free response questions over the years, you'll see that these are pretty common. You just ask it maybe a little differently, but very similar, or if not the same actually. Okay, so we're asked to find the acceleration vector. So do we have the velocity vector? We don't, per se. We have the x component of the velocity vector. Okay, so we got to find the velocity vector first, which is the first derivative. Okay, so x of t, y of t, that's the position vector. Velocity vector is x prime of t, y prime of t. Okay, and then the acceleration vector is the derivative of the velocity vector, or the second derivative of the position vector. So that's what I wrote over here. Okay, and then just to show work, x double prime is the first derivative of x prime, which they gave. So derivative of e to cosine t, which is e to cosine t times minus sine t, chain rule, okay? And then we need to take this derivative twice. So that's what I wrote here. You can also write the d squared over dt squared notation. That works as well, okay? So derivative of 2 sine t is 2 cosine t. Derivative of 2 cosine t is minus 2 sine t. I'm not sure if you need to show the derivative of 2 sine t. I just did it all in my head. I would show the work if you have time, but honestly, if I were to grade, I wouldn't be too picky. The scoring guidelines weren't very clear either, so I'll leave it up to you. But this is the acceleration vector. So the a of 1 is you plug in t equals 1, and then you need a decimal answer, so plug into your calculator. Okay? This one's asking for the first time t at which the speed of the particle is 1.5. Speed is the magnitude of velocity. Okay? So we're interested in when the speed is equal to 1.5. That's what the question said. What's x prime of t? They gave that to us. Y prime of t, earlier we said was 2 cosine t, right? So right there. Okay, so you set this as one equation in the calculator. Set this as another equation. Find the points of intersection. That's one way to go about it. Or you can use the equation solver. That also works. You'll find that t is 1.254. Okay, find the slope of the tangent line at t equals 1. Find the x-coordinate of the position of the particle at t equals 1. So slope of the tangent line, that's derivative. So remember how to find the derivative of a parametrically defined equation. The slope, which is dy dx, is dy dt over dx dt. So we had dy dt, 2 cosine t. We have dx dt that was given. Okay, this is our dy dx. We're interested in the slope of the tangent line at t equals 1. So evaluate it at t equals 1. Okay, so then I don't know if you need to write that, but in the calculator, you would get 0.6295. So here's the slope. We need a point though. It's at t equals 1. So what's the, actually that's the slope. It didn't ask for equation, so that's the slope. Now it says find the x-coordinate of the position of the particle at time t equals 1. So how do we do this? If you watch the 2024 video first, because I filmed that first, as I said in that video, this is a very standard problem. We have to know how to set up the integral, as I was saying over there. Because this integral antiderivative is quite challenging to find. Even I'm not sure exactly how to find it. Okay? So we could find the antiderivative of this and then plus c and then use the initial condition to find that c. But again, this antiderivative is challenging to find. So let's think about it a little differently. Let's use fundamental theorem calculus. x of 1 minus x of 0 is the integral from 0 to 1 x prime of t dt. This is fundamental thing in calculus, right? This right-hand side, we can plug into our calculator. F int e to the cosine t, comma x, comma 0, comma 1. Something like that, right? If you have the TI-84s. I remember that's how you input it in. Okay, and we're given x of 0 because at t equals 0, the x coordinate is 1. So we're interested in x of 1, right? So let's move this x of 0 on the other side. So x of 1 is 1 plus, because remember I just said that's given, and this you find in the calculator, so you just get 3.3416 as your answer. Okay? Part D, find the total distance traveled. This, if you again watch the 2024 video first, is just arc length. Here's the setup, and put it into your calculator. That is your answer. We've got to remember the arc length formula for parametrically defined equations. Okay, that's it for this video. Hopefully this was helpful. Again, very standard problems in this question from this year. So study well and understand how to do these. Okay, hopefully I'll see you in another video as well. Bye.